what would they know? What's the general definition here? So general, oh shit. General definition. For n greater than or equal to 1, the length of x with some components, x1, x2, x3, x4, so on, so on, so on, is root of x1 square plus x2 square plus x3 square plus so on, so on, so on, so on, plus xn square. So in R2, it would be a square plus b square. R3 would be a square plus b square plus c square. Okay, so what's the general definition? So for n greater than or equal to 1, length for x equals x1, x2, so on, so on, so on, xn would be root of x1 square, x2 square, x3 square, so on, so on, so on, so on, xn square. So where R2 would be root of a square plus b square, R3 would be root of a square, b square, c square. So I got myself a cup of coffee. Yeah, I got myself a cup of coffee. Alright, so if I have v is equal to minus 3 and 4, and the absolute value we know that obviously. So example 1.2, so example 1, let's say example 1. If I have v is equal to 3 and minus 4, then that magnitude of v would be 3 squared plus, oh shit, magnitude of v, the root of 3 squared, what are you doing, plus minus 4 squared, which is 16, 5. So suppose v is ABC, so that question there, see if you guys can see. So suppose v is ABC, that's coffee, that's black coffee. So suppose v is ABC and k is scalar, and kv is ka, kb, kc. Okay. Some reading check 1. So suppose v is ABC and k is scalar, and kv would be ka, kb, kc. And so simply if I were to do the magnitude of kv, I'd simply have a root of ka square, kb square, kc square. Or I can do root of k square, a square, b square, c square. Or I can do root of k square, root of a square plus b square plus c square. There will simply be kv. So if I have a vector and a scalar multiple, then simply put kv would be written as kv, as this guy is a scalar product, scalar value or scalar constant, and this is the vector component. It is pretty hot. I'm going to leave the window open. Cool, the window is open. Can't wait for snow to start. It's still pretty hot, not gonna lie. It's actually hot. You have a smiley face. Do you see that? Got a smiley face. Alright, moving on. If k is a real number, what is the root of k square? How the fuck am I supposed to know what is the root of k square? Yeah, don't care. A unit vector is a vector of length 1. So each of these is a standard basis vector. So E1 would be 1, 0, 0, 0, 1, so on, so on, so on, so on, so on. So the position is like a diagonal. Okay, so what is a unit vector? Put the fan on my side, it's too hot in here. Hell yeah, I brought the fan too close to my side cause goddamn it's hot. What? Why would I not bring the fan towards me. I bought this fucking fan with my own money. But what is a unit vector? Unit vector is simply vector of length 1. So which means if I were to have an R2 vector, then I would have root of a squared plus b squared, this would equal 1. Or if I were to have an R3 vector, then I'd have a root of a squared, b squared, c squared equal to 1. It doesn't matter how many vectors, how many vector components we have, but if I were to find the unit vector length, that should equal 1. So if I were to look at this example, obviously that's a dreaded, unnecessarily big but easy example. So if I were to have E1, which is represented as 1 0 0 0 0, E2 as 0 1 0 0 0, and so on so on so on, En, this is the standard basis vector 0 0 0 all the way to 1. So if I were to add all those, I am going to have E1 plus E2, E1, which is simply vector component of 1 root of 1 plus 0 plus 0 plus 0 plus 0 plus 0 plus 0, which is simply 1. And if we do the same for E2, it would be 0 plus 1 plus 0 plus 0 plus 0 plus 0, which is 1, and then 1, and then 1, and then 1, and then 1. So if I were to use a realistic example, so let's use a realistic example. So realistic example, so if I were to use a realistic example, for example, if I said that I'm going to use the example here, 1 by root 2, 1 by root 2, if I were to add 1 by root 2 square is what? Half plus half, square, 1 by root 2 square, so that is half plus half, which is root 1, which is 1. And the same thing here, if I do 1 by root 6, which is 1 by 6, plus 4 by 6. So 1 by 6 plus 4 by 6 is 5 by 6. 5 by 6 plus 1 by 6 is 6 by 6. 6 by 6 is 1, and root 1 is 1. Cool? So this is half plus half, and this is 1/6, 4/6, 1/6. Right? Okay, for any vector v, the vector 1 by magnitude of v, v is the unit vector in the direction of what? V is the unit vector in the direction of v. Okay, for example, to find the unit vector in the same direction as v, 2, minus 2, and 1, we compute some k. So k would be root of, k would be the magnitude of v, which is 3, because 4 plus 4 plus 1, which is 9, and root 9 is 3. The desired vector is 1/3 v. So okay, I understood. I'm going to use this example to define that, which is pretty easy to understand. I'm going to use this example here. So if I have v as 2 minus 2 1, and if I want to find the unit vector and they're in the same direction, opposite direction would be negative, same direction or parallel direction would be positive. So I can simply write v would be root of 4 4 1, which is 3. And so if I want to find the unit vector, my kv, this k would simply be 1 by magnitude of v times v, which would simply be 1 by 3 times the vector of 2, minus 2 and 1, which then leads to 2 by 3, minus 2 by 3 and 1 by 3. Right, dot product and angle between vectors. Let v equals some vector xy be a two-dimensional vector. If v is 1, then x squared plus y squared is 1. This means that if v is pictured by an arrow that starts at the origin, then the arrowhead lies on the unit circle. Since any point on the unit circle has coordinates of the form cosine of alpha, sine of alpha, it follows that any two-dimensional unit vector is cosine alpha, sine alpha for some angle alpha. Wait, what's going on? Let v of xy be a two-dimensional vector I'm confused. Wait. I'm fucking confused. What's going on? This means that if V is pictured by an arrow that starts at the origin, then the arrowhead lies on the unit circle. Since any point on the unit circle has coordinates. Okay, I understood. So, very simple. If I go back to this part here, how do I okay, you know what? Let's draw it out. Let's actually draw it out. So this is dot product and angle between vectors. So dot product and angle between vectors. So you can see that if I look at the graph here, right? I have some coordinate AB, right? Some coordinate AB. And my vector is represented as some value A and B. Same thing, but this is in terms of a line graph. I know, line, some kind of line. If I implemented same procedure, but this time instead of a line, we have a sphere or a circle. So if I draw the same coordinates again, if I draw the same thing again, draw a circle here, maybe this, for example, this coordinate here will be cosine alpha, sine alpha. This will be my coordinate, and obviously you know the equation for the circle, which is x squared plus y squared is equal to 1. And so if I were to represent this vector, this coordinate is a vector, then v would be cosine alpha, sine alpha, right? For any angle alpha. So this is only applicable for any vector where length will be equivalent to 1. So let's say if I know the circle and I can find out that okay, my vector length is 1, then if I can do this v, which is root of x squared plus y squared, which then leads to 1. Eventually, if I can get this, only then I can say that okay, my coordinates here would be some coordinate cosine alpha, sine alpha, and I know my vector, which would be in the form cosine alpha, sine alpha, right? Go with what? Okay, now we are focusing on this guy. Oh shit. We are focusing on this section here. The bracket here, and I'm gonna draw out the second curve with this curve here. Draw that out. let's draw out. So we have some coordinate cosine alpha, cosine, we'll call that cosine alpha for now. I know here it says cosine beta and sine beta, but I'm going to say cosine alpha, sine alpha. And I'm going to call that V, and U would be cosine beta, sine beta. Alright, so which one's the, so this will be alpha, this will be beta. So I can see that the change in angle would simply be alpha minus beta. In this case it will be beta minus alpha, but in our case it will be alpha minus beta. So change in angle would be alpha minus beta. Okay, suppose U is, so in our case U is cosine beta sine beta, and V is cosine alpha sine alpha, each having a length 1. And so for convenience, let's suppose that 0 is less than alpha, less than beta, less than pi by 2. And so the angle between U and V is beta minus alpha. So in our case it will be alpha minus beta. And the author is hoping that you, so if I were to write alpha minus beta, if I were to write cosine of alpha minus beta, then I'm going to have cosine alpha cosine beta minus plus, is it plus? Sine alpha sine beta. Actually no, if you know what, let's write what they know. If I have cosine of beta minus alpha, then I'm going to have, because I know that there is another way where you have subtraction instead of usual addition. If I have cosine beta cosine alpha minus sine beta plus sine beta sine alpha, look at the right hand side. This is the product of the first coordinates of U and B, U and V added to the product of the, what? Oh God. If the theta of the angle is between the unit vectors U and V, then cosine theta would be A1, A2 plus B1, B2. So in general case, would be cosine theta. So technically U dot V would be A1 V1, actually A1 A2 plus B1 B2. General, not forget about the angles and stuff, but general. So if I were to use, in this case, U times V would be cosine beta cosine alpha plus sine beta sine alpha. Actually, it will be cosine alpha cosine beta, right? However, whatever the case, cosine alpha, cosine beta, cosine alpha, doesn't matter. So cosine alpha, cosine beta plus sine alpha, sine beta. General case, u times v would be a1, a2 plus b1, b2. So the general definition of dot product is what? How many pages left? So 45, 46, 47, 48, 49, 50, 51, 52. Oh, okay. I think there are more questions than notes. As far as what I can see, there are more questions than notes. As far as what I can see, there are more questions than notes, and which makes sense for the first few chapters. Not much notes is required, but questions are required. Okay, so general definition of dot product is what? So general definition of dot product will be what? So if I were to have u with some vector a1, a2, a3, so on, an, and if I have v with some vector components b1, b2, b3, so on, bn, then u times v would be a1, b1, a2, b2, a3, b3, a4, b4, so on, plus an, bn. So this is the entire equation for the dot product of u times v. So if I were to do the example there, let's do the example actually. So if I were to do the example, so if I have u as minus 1 and 2, and if I have v as 4 and minus 3, then simply if I were to do uv, then I have minus 1, 4 plus 2 minus 3, which would be minus 4, minus 6, so minus 10. And I would do the same thing for, even if I have a 5 vector component, 6 vector component, 7 vector component, it doesn't matter. Okay, what's this? The vectors u, which is 1 by root 2, 1 by root 2, and v is minus 3 by 5 and minus 4 by 5 are unit vectors. So the cosine of the angle is cosine theta, which is u times v, which is 1 by root 2 times minus 3 by 5 plus 1 by root 2 times minus 4 by 5, and they have already said it, which is minus 3 by 5 root 2 minus 4 by 5 root 2, which is minus 7 by 5 root 2. And then you do, oh shit, okay, you cannot use a calculator. So theta, so cosine inverse of minus 7 by 5 root 2. Shit, you cannot use a calculator. We know that. Now the angle between vector is in the angle 0 less than or equal to theta less than or equal to pi. If theta is the angle between the unit vectors and cosine theta is uv, so I have two equations here. What is the angle between u and v in general? So nothing. So the angle in question has nothing to do with the length. So this is the same as the angle between unit vectors having the same direction. So if I were to find the angle, the cosine theta would be 1 by the magnitude of u times 1 by magnitude of v, which is simply 1 by magnitude of u, magnitude of v multiplied by u dot product v. Or simply I would have u dot product v divided by u, so I'd have u times v divided by magnitude of u, magnitude of v. So this is my cosine theta. Or you can write u times v is u v cosine theta. Oh, if u is root 3 by root 3 and 1 and v is 1 by root 3, then u times v is root 3 times 1 plus 1 times root 3, which is root 3 by root 3, which is 2 root 3. And so simply the magnitude of u would be root 3 square, which is 3, plus 1 square, which is 1, so root 4, which is 2. And cosine theta is u times v divided by, actually, let's do that. So if I have u as root 3 and 1 and v as 1 and root 3, okay, cosine theta is u times v divided by magnitude of u, magnitude of v. And on top of that, if I were to have u as root 3 and 1 and v is 1 by root 3, then I can do the dot product first. So in simple case, dot product would be u times v, which is simply root 3, 1, 1, root 3. So that is 2 root 3. U would be root 4. V would be root 4 to 2. And so we know that cosine theta simply u times v divided by u. So the u times v, actually you guys can't see, right? So that'll be, oh, okay, you guys actually cannot see. Can you guys see now? Is it better? Okay, no lights are better. I think so. So you guys weren't able to see? Holy crap, you guys weren't actually able. The only reason I use light is because when I don't switch on the light, it gets so bright that it hurts my eyes. So you see that there's a root 4 there, and so I'll have u times v divided by magnitude of u, magnitude of v, and so cosine theta would simply be 2 root 3 divided by 4, and so cosine, so I will have, actually let's check, cosine theta would be root 3 by 2, and we know that by the table we know that cosine inverse of root 3 by 2 would be pi by 6. Right? Let's heat up my coffee. Okay, so let's do another example. Oh shit. So you have 1.2.16. So let's suppose u was 1, 2, minus 3, 1. So u was 1, 2, minus 3, 1. And v was minus 2, 1, minus 1, 4. And so eventually my absolute value of u would be 1491, 13, 15. And so v would be, let's see, that's u there, and this is v here. Should be 4, 1, 1, 16, root 22. So u times v would be minus 2 plus 2, which is 0, 3 plus 4, which is 7. So cosine theta would be 7 by root 15 times root 22. Now root 15 is what? Actually, how do you calculate root 15 by root 22? How the fuck do you calculate root 15 by root 22? So theta would be cosine inverse 7 by root 15 root 22. Actually, no, really, how do you calculate it? What is root 15 times root 22? No idea. But the book says theta would be at approximately 0.385. No, sorry, not 0.385, it would be around 1.175. rads, or 67.3 degrees. Shall we move to the next one? Let's move to the theorem now. Let's move on to the theorem, or the properties of dot product. Right, so commutative, distributive, associative, then multiplicative, right? So multiplication, or whatever you call it, right? So commutative would be, these are basic theorems. Dot product theorems. So commutative would be u times v is equal to v times u. Then distributive, if I have u times v plus w, then this would be uv plus uw, where each of them is a dot product, and if I have v u plus w, that would lead to vu plus vw. Then scalar associatives, if I have this is commutative, distributive, scalar associative, if I have cu times v, this is the same as c uv, which is same as cv u. And then we have the other one, which is the multiplicative by itself. So multiplication by itself, v u times u, which is u square. I think we finished completely.